Hello and welcome to Teach Me in 10. For this episode, we're joined by James Swinyard, a Senior Director of Investments and Partnerships at My Green Lab. James explains why Scope 3 emissions, the carbon hidden throughout the lab supply chain, represents one of the biggest challenges facing life science organizations. He'll break down what Scope 3 emissions are, why they're so difficult to measure, and how scientists, procurement teams, and operations leaders can work together to reduce their environmental impact. Hi, James. Thanks for joining us. So to kick things off, can you walk us through the three scopes of greenhouse gas emissions and why Scope 3 is the one that most organizations don't actually talk about?
Yeah, sure. Thanks for having me, Laura. I'm excited to be here. Happy to talk through the three scopes. So the greenhouse gas protocol divides emissions into three categories or scopes that together comprise an organization's overall carbon footprint across its value chain. For Scope 1 emissions, these are the direct emissions from sources a company owns or controls in a laboratory environment. That can include natural gas burned for heating, fuel used in company vehicles. It could be backup generators or refrigerant leaks for cooling systems. For Scope 2 emissions, these are the indirect emissions from purchased energy. So, for example, the electricity used to power freezers, fume hoods, clean rooms, analytical instruments, and then even the office space itself. The emissions occur at the power plant, but because the organization consumes that electricity, they're accounted for in the Scope 2 portfolio. For Scope 3 emissions, these encompass everything else up and down the value chain. Upstream, that includes purchased goods and services, laboratory supplies and reagents, equipment, transportation, waste, and business travel. Lots of stuff in Scope 3. So downstream, it can include product distribution, product use, and end-of-life treatment as well. The reason why Scope 3 gets less attention is pretty simple, and you've probably already gathered this. It's way harder. Most organizations have direct visibility into their utility bills, fuel consumption, and facilities. They can measure those emissions reasonably accurately and have direct control over reducing them. Scope 3 requires understanding emissions that occur outside the organization's walls. For many large pharmaceutical companies, Scope 3 emissions account for more than 90% of total emissions. Once an organization has made progress on energy efficiency and renewable electricity procurement and facilities improvements, the next major lever is engaging the supply chain. That's why attention to Scope 3 is often a sign of sustainability maturity. Organizations have moved beyond managing what they directly control and started addressing the much larger impact embedded in the products and the services that they purchase.
Amazing. And yeah, you did touch on it a little bit there, but why is Scope 3 so much harder to measure and act on than Scopes 1 and 2? And what makes the lab supply chain especially complex?
A pharmaceutical company may have visibility into the electricity consumed by a laboratory, but understanding the carbon footprint of every pipette tip, reagent, freezer, chromatography column, or single-use bioprocessing component requires information from hundreds or even thousands of suppliers. It's incredibly complex. The life sciences sector is particularly complex because modern research relies on highly specialized products with global supply chains. A single item used at the bench may involve raw material extraction in one country, manufacturing in another, assembly somewhere else, and distribution through multiple logistics providers before it even reaches the laboratory.
So for a typical biotech or pharmaceutical company, how significant is the lab supply chain as a source of Scope 3 emissions?
Yeah, great question. So it surprises a lot of people. When you think about emissions, they tend to picture buildings, electricity, transportation. In reality, for many life science organizations, emissions associated with purchased goods and services are among the largest categories within Scope 3. Our data suggests that for most medium to large pharmaceutical companies, around 90% of their overall carbon impact can be attributed to Scope 3 emissions. And of their Scope 3 portfolio, over 80% of those emissions are coming from Category 1, their purchased goods and services.
And I'm imagining now that I'm a scientist at the bench, Scope 3 emissions can feel quite abstract. The carbon is happening somewhere else in someone else's supply chain. What's the most direct line between what a scientist orders on, say, a Tuesday morning and the organization's Scope 3 footprint?
Sure. So yeah, the most direct connection is that every product a scientist purchases comes with embedded emissions. That's just the truth. Before a box of pipette tips arrives in the lab, raw materials had to be extracted, processed, manufactured, packaged, stored, and transported. Carbon emissions were generated at every step along the way. Scientists may not see those emissions directly, but purchasing decisions drive demand, and demand drives production. This doesn't mean that scientists need to become carbon accountants. It means recognizing that product selection can be a sustainability decision. Choosing a lower carbon alternative, consolidating orders, extending equipment life where appropriate, or selecting suppliers that provide transparent environmental data can all influence Scope 3 emissions without compromising science. And so scientists have more influence than they often realize.
And I guess collecting or tracking Scope 3 data is one thing, but knowing whether you can trust it is another. So when a procurement manager asks a supplier for Scope 3 emissions data, what should a credible answer actually look like? And how do you tell the difference between genuine transparency and greenwashing?
Yeah, this is a really important question, Laura. And a credible answer should really go beyond sustainability claims and provide transparent, third-party verified data. So suppliers should be able to explain how emissions were calculated, what standards were used, the assumptions that were made, and the boundaries included in that assessment. Product carbon footprints, or PCFs, are becoming more common in life sciences, but they have limitations. Without widely adopted product category rules, suppliers can utilize different methodologies, use different assumptions, and rely on different data sources, making PCFs difficult to compare across similar products. Today, they're often more directionally informative than directly comparable. And that's why tools like My Green Lab's Act Ecolabel are so valuable. Developed in collaboration with stakeholders across the laboratory industry, ACT evaluates products using a standardized framework that looks beyond carbon alone. It actually assesses the factors we know have an outsized impact on sustainability, including manufacturing practices, facility operations, energy and water use, packaging, materials, and end-of-life considerations. This provides procurement teams with a more consistent and actionable way to compare products and suppliers and really fills in a lot of the gaps that PCFs leave. Ultimately, I think the biggest differentiator between genuine transparency and sustainability theater is whether a supplier can show the data and methodology behind the claims, because otherwise it's really just marketing.
Absolutely. And Scope 3 emissions are partly a legacy problem that's baked into supply relationships, contracts, and equipment choices made years ago. For someone in an operations role, how do you work within those existing constraints while building towards something better?
Yeah, so I think the key is not to let the perfect be the enemy of progress. Most organizations can't replace all of their suppliers. They can't redesign all of their products or rewrite all of their contracts overnight. We know that's not realistic. I think instead, successful organizations start by understanding where emissions are concentrated and identifying practical opportunities to influence those areas over time. It's really a step-by-step process. And that may mean incorporating sustainability criteria into future procurement decisions, prioritizing engagement with strategic suppliers, extending equipment life cycles, reducing waste streams, or supporting scientists in evaluating lower impact alternatives, as we've discussed. The organizations, I think, making the most progress aren't waiting for a perfect future state solution. They're really embedding sustainability into routine decision making today, so that each contract renewal purchasing decision and process improvement moves them in the right direction.
So it's clear, James, from what you're saying, that reducing Scope 3 emissions isn't something that any one team can do alone, and it requires scientists, procurement teams, and operations leaders to all be pulling in the same direction. But in most organizations, those groups don't naturally talk to each other about sustainability. What does meaningful cross-functional alignment look like, and who usually needs to drive it?
Yeah, absolutely. So the organizations making the fastest progress have moved sustainability out of a single department. Scientists understand product performance. Procurement teams manage supplier relationships. Operations leaders understand facility and process efficiency. And sustainability teams provide the strategy, measurement, and reporting to support continuous improvement. And meaningful alignment then occurs when those groups share common objectives rather than competing priorities. In practice, That often means establishing sustainability criteria in procurement processes, giving scientists access to environmental information during product and supplier selection, and ensuring leadership supports those efforts through clear goals and accountability. Executive sponsorship is usually essential. Without leadership support, sustainability often remains an optional consideration. So I think really the key is getting all of these teams to talk to each other, align on a common goal, and then get their executive teams to sponsor that.
Yeah, absolutely. And my final question for you is about Scope 3 reporting, as it's increasingly showing up in regulatory frameworks and investor disclosures. But what does that mean for life science organizations that haven't started measuring their lab supply chain emissions yet? And how urgently should they be acting?
I think the most important message is that this is no longer just a sustainability issue. It's a business issue with real risk associated. Investors, customers, regulators, and procurement teams increasingly expect organizations to understand and disclose emissions across their value chains. Even when companies are not directly subject to reporting requirements, they're often asked to provide emissions data to customers who are. And the organizations that now have the time to build internal capability, improve data quality, engage suppliers, and establish credible baselines are the ones that are going to be ahead of the curve. And those that wait may find themselves scrambling to meet customer, investor, or regulatory expectations. I think the good news here is that measurement doesn't have to be perfect on day one. The most important step is really getting started. And you can't manage what you don't measure, and you can't influence what you don't understand. So for life science companies, I think the question is no longer whether supply chain emissions matter. I think that's clear that they matter. The question is how quickly they can build the visibility and partnerships needed to address them.
Lovely. James, thanks for breaking down such a complex topic so clearly. It's been really great chatting with you.
Likewise, Laura, thanks so much for your time.
Thanks. Bye. Thanks for watching this episode of Teach Me in 10, brought to you by My Green Lab. To learn more about Scope 3 emissions, sustainable laboratory practices, and My Green Lab's certification programs and resources, check out the links in the description. And if you enjoyed this episode, don't forget to like and subscribe for more episodes. Bye for now.